All right, finally we have the FRQ. With this one, should be a type of problem which you're quite familiar with at this point. That being said, especially Part D is going to take some meticulous work in order to make sure that you earn all of the points. All right. Part A is a quick hitter. We want G of 3, G prime of 3, G double prime of 3. All right. What are we given? We're given the graph of F on the domain 0 to 7, consisting of 4 line segments, and G is equal to the integral from 2 to x of f of t dt. Right away, we make this the graph of G prime, which means it's real quick to get G prime of 3. Since this is the graph, we can see we want that point right there. G prime of 3 is 2. G double prime of 3 would be the derivative of G prime at this point. The derivative is the slope of the tangent line. Because the function itself, G prime, is linear at this point, we just need to find the slope of this line, and we can clearly see that the slope is down 2 and over 1. So G double prime of 3 is negative 2. And then finally, we want G of 3. Here's G of x. So G of 3 would be the integral from 2 to 3 of f of t dt. The integral from 2 to 3 would be this region here, which is 1, 2, and then a third block there. All right, that triangle, that upper triangle, is base of 1, height of 2 for an area of 1. So 1 plus 1 plus 1 is a final answer of 3. Part B, even quicker. We want to know on what intervals is G increasing, and we must explain our reasoning. So let's do the reason right away. All right, because G, sorry, wrong case. G increases when F, which is equal to G prime, is positive. So go back here. When is our derivative of G positive? From 0 all the way to 4, and then again from 6 to 7. So we want to write both those intervals down. And we're all set. Part C, find the x-coordinate for each point of inflection on the graph over this domain. Justify your answer. All right, so again, let's do the answer first. All right, we know that a function will have a point of inflection. All right, so we'll write G has a point of inflection when G prime, which is equal to F, and again, you can write any one of these. G prime, oops, I'm sorry, I'm off the screen here. G prime equals F, or just F, because we already up here mentioned that F and G prime are the same. When G prime equals F, changes from increasing to decreasing, or decreasing to increasing. All right, so we use our knowledge of our connections. Now go back here for changing from increasing to decreasing. That's the top of a mountain. Boom, right at 2. Decreasing to increasing, the bottom of the valley, right there at 5. So x equals 2, comma, 5. And now part C is done. Okay, D is going to take the most time here. Find the minimum value. Right? We don't see the word written, but it is understood to be there. Find the absolute minimum value of G on the interval from 0 to 7. Show the work that leads to your conclusion. All right. So first things first, we need our candidates. All right, the candidates are the endpoints. and the critical points. Critical points are where the derivative of g is equal to 0. So that's 4 and 6. Those are the 4 candidates. We want to make sure that we check all 4. So we're going to need g of 0, which will be the integral from 2 to 0 of f of t dt. And we're going to need, if we go in increasing order, g of 4, which will be the integral from 2 to 4 of f of t dt. And we're going to need to find g of 6, and we're going to need to find g of 7. Okay. So back to the beginning, g of 0, we see an integral. The bounds should be swapped, so that's the opposite of the integral from 0 to 2 of f. So let's get that integral. 0 to 2 is this triangle right here, base of 2, height of 4. So half of 2 times 4 is 4. So the area is 4. But we need that negative sign. Sorry, that was off the screen there. All right, there we go. We need the negative, and then the integral is equal to 4. Next up is the integral from 2 to 4 of f. Well, we already did 2 to 3. Now we're just going to include the rest of that triangle right there. So we have the exact same size triangle as we did a moment ago. Base of 2, height of 4. That's 8. Half of 8 is 4. So there's g of 4. Now we need g of 6. G of 6 is the integral from 2 to 6. So we already have 4 right here. And we're going to get rid of, or take away that area. That's a triangle with a base of 2 and a height of 1. So half of 2 is 1. However, as we know, it is negative. So we're going to have 4 minus 1, or 3. And finally, if we go all the way up to 7, we're going to add in another half a unit. So we have all the way up to 6, which is our 3, minus another half. I'm sorry, plus another half, not minus, plus another half, which is equal to 3.5. So clearly, the smallest value, or the absolute min, is negative 4. So negative 4 is the minimum value of g on the interval from 0 to 7. All right. Always good to put that concluding statement down. Double check that you have everything correct in that statement. But we need to see the work on all of the candidates in order to read your conclusion.